Here's a solution for day 4, problem 1. Sketch the graph of f of x equals 1 plus the sine of x. In a previous bellwork assignment, we had a similar function. We had f of x equals sine x. It just didn't have this additional plus 1 to it. Hopefully you recall that that created a wave-like function. Now we can use the unit circle to help us find values for sine x. We just need to add 1 to those answers that we get from the unit circle. On the x and y axis, the origin is at 0, so let's find the sine of 0 from the unit circle. Looking at the unit circle, the sine of 0 is 0, and then adding 1, we get 1. So when x is 0, f of x equals 1. So 0, 1 is a point on the graph. Now another value on the unit circle that we can look up is pi over 2. So the sine of pi over 2 turns out to be 1, and then 1 plus 1 is 2. So when x is pi over 2, the function turns out to be 2 up here. Another number that we could look up on the unit circle is pi. The sine of pi is 0, and then adding 1, we get 1. So when x is pi, f of x turns out to be 1. This spot right here between pi and 2 pi is 3 pi over 2. So let's look at the unit circle for the sine of 3 pi over 2. It is -1. And then when we add 1 to that, we get 0. And so 3 pi over 2, 0 is a point on the graph. And the last one to look up, let's look up 2 pi. The sine of 2 pi is 0, and then adding 1, we get 1. So 2 pi, 1 is a point on the graph. If we connect these dots together, we get that wave function that we've seen before. Notice that it's the same wave function that we had a few weeks back for the function f of x equals sine x, but the wave function has been shifted up 1 unit because of that additional plus 1 constant term. Now this is only one period of an infinitely long wave, so let's extend it a little bit farther to the left. We have room to the left on this grid. First of all, let's mark this spot. This is negative pi over 2. And then we'll mark this spot here in between negative pi and negative 2 pi. This would be negative 3 pi over 2. And coming down here, it's going to come down to that spot. So we can swing down like that. And then it's going to come up to that spot. So swing it up to there. And then coming above the negative 3 pi over 2, it's going to be up there at that height of 2. I had messed up there earlier. That's a 2 there on the y-axis. So it's going to come up and curve there. And then it will come down to there. And it's going to keep going, but that's as much room as we have on this graphing window. Day 4, problem 2. Find the sum of the first 40 terms of this arithmetic sequence. Arithmetic sequences have common differences, or a constant rate of change between terms. In this case, that common difference appears to be 5. It's increasing by 5 each time. There's a formula we can use to find the sum of an arithmetic sequence. The formula looks like this. S sub n equals n divided by 2 times the first term of the sequence. We use a sub 1 to represent that, plus the last term of the sequence. We'll use a sub n to represent that. What we can plug in so far is 40 for n. We want to find the sum of the first 40 terms. So that will be 40 divided by 2 times the first term is negative 4 plus, and then we want to do a sub 40, the 40th term. But we don't currently know what the 40th term is. So let's find that. One way to find the 40th term is to first find a formula that will get us any general term that we want. Arithmetic sequences have a constant rate of change, so we can create a linear equation to represent them. The rate of change is 5, so 5n starts our formula. But we might need to put an adjustment on the end. So when n is 1, 5 times 1 makes 5, but the first term isn't actually 5, it's negative 4. We would need to subtract 9 from 5 to get negative 4. Let's test this and make sure it's correct by putting 2 in for n. 5 times 2 is 10. 10 subtract 9 is 1. So the second term turns out to be 1, and that is confirmed here. So this is the correct general formula to find us any term we want, and we want to find the 40th term. So we can go 5 times 40, subtract 9. 5 times 40 is 200, and 200 subtract 9 is 191. And now we know what number goes here. The first number in the list is negative 4, and the 40th number in the list is 191. So let's go back to finding the sum of the first 40 terms. 40 divided by 2 is 20, and negative 4 plus 191 is 187. Multiply these together and we'll have the sum. The answer is 3,740.